Alright, today we are going to write and solve systems for real-world situations. So this is the last target of Unit 5. Alright, so whenever reading a word problem, you always want to define your variables as specific as you can. So a lot of times we have our x and our y, and students would say, well, x is dogs and y is cats. When in reality, you're talking about the number of dogs or the number of cats. So that's just an example of how you can define your variables as specific as you can. Instead of just saying dogs and cats, write down the number of dogs, the number of cats. So you got to be really specific in terms of how you want to identify what your variables are in word problems. It'll help you understand what you're reading and what you're trying to do. So typically at your level right now, when you write your own equations for each system, you're going to have 2 or maybe 3 equations that you have to write, and each equation that you have to write has its own little situation going on. So the first type of situation that you might have with 2 variables would be that you're comparing how one is in terms of the other. So you can say the number of dogs is 5 times as more as the number of cats. That representation, that translation would be equation number 1. So look for if you're comparing 2 variables in the situation that you read. Another would be telling you how much each variable or the worth of each variable would be. So if you're talking about, let's say, you're buying pets at a pet store, it'll tell you the number of it'll tell you how much each dog would be or how much each cat would be, depending on if it's the same type of cat or dog. Or you would have to figure out how much each item would cost. So that can go hand in hand. It can be reversible, but just basically the value or worth of each variable also comes into play when you write your own equations. So then finally, what I've noticed is that you also have to write an equation where it tells you the number, not specifically of each item, but how much they total up to. So it'll say the number of dogs and the number of cats together would be 32. Or Mary was able to buy a total of 15 donuts, a total of 15 items at the bakery when you're talking about donuts and pastries, let's say. So that would be a specific equation that you'd write for that situation. So you got to really read the content and pick out and identify, well, are we comparing 2 variables? Are we talking about the value of each worth, or the value or worth of each variable, or what the total, are we going to have to describe what the total number is after each variable is combined? So look for these 3 things. There are obviously going to be more different situations, but these are the ones that I found common in Algebra 1 that you've been working with. Alright, example number 1, all we have to do is write the linear system that models the situation. So it says, during the summer, you want to earn $200 per week. You can work as a lifeguard and make $10 per hour. You can also work at the local grocery store and make $8 per hour. For 1 week, you work a total of 21 hours between the 2 jobs. How many hours do you work at each job? Alright, so the first thing that you want to identify after reading a word problem is to define your variables as specific as you can. So it seems like, if we're asked how many hours do we work at each job, it seems like our 2 variables would be the number of hours at each job. And so what we have to do is, well, what are the 2 jobs? Well, we need to know that, well, we're going to say X is going to be the number of hours at the first job we have as a lifeguard. Right here. At lifeguard. And then let's say our Y would be the number of hours at the grocery store. Those are our 2 jobs, grocery store. So to save some space, let me just rewrite this really quick on the side, and it'll be a little bit smaller so I have some place to work. So you got the X is the number of hours at the lifeguard, or being a lifeguard, and then the number of hours at the grocery store. So you actually have two situations going on in this specific word problem. You have the idea that you want to make $200 per week, and you also have the fact that you work a total of 21 hours in the 1 week between the two jobs. So we have to figure out how we're going to make two sentences or two equations based on this situation. So if we go back to our earlier presentation, we have the total number for each variable combined, and we also have the value of the worth. When this one right here would talk about the fact that we want to make $200 per week, and this is the fact that we have 21 hours between the two jobs. That's how much time we've spent at work for the 1 week. So knowing our two situations, let's work on one of the situations at a time. So equation number one, we know that we want to earn $200 per week. That's key. So then how are we going to make that $200? Well, we know that we work at two jobs, as a lifeguard and at the local grocery store. So if we're talking about our variables, X being the number of hours at a lifeguard or at the lifeguard position, and then Y being the number of hours at the grocery store, well, it says that we make $10 per hour at the lifeguard position, and we make $8 per hour at the grocery store. So if you think about how we can actually total that up to be $200 of our time spent at our jobs, well, we know that our total has to be $200. To make that $200, we have to spend, we get paid $10 an hour at the lifeguard position. So in addition to that, we make $8 per hour at the grocery store. So this equation right here would represent how much we would make in the summer if we wanted to earn $200 per week. Alright, so the second situation that we have going on deals with the total number of hours that we've worked between both jobs. Again, the two jobs are being a lifeguard and then the grocery store. So if we know that the total number of hours is 21, well, that's our total right there, 21 hours. So then that being said, we've defined our variables as the number of hours at the lifeguard position for X and the number of hours at the grocery store for Y. So if the total is 21 hours, our second equation would just be X plus Y equals 21. These two equations would represent the system in the word problem that we've just read. Alright, the second example, we have to actually solve the linear system that models the situation. So a lot of us like to jump ahead and want to solve right away, but we can't solve until we know how to write and define what our variables are in our system. So the situation says a rectangle has a perimeter of 14 feet. Twice the length of the rectangle is equal to 1 less than 4 times its width, W. Write and solve a system of linear equations to find the length and the width of the rectangle. So before we even write our equations, we have to define what our variables are going to be. So it says that we have a length and we have a width, W. Instead of W, I'm going to stick with a different variable. I'm going to say X is our length and Y is going to be our width. Okay? Alright, so let's get to our equations. So equation number one, we're dealing with the fact that the perimeter of the rectangle is 14 feet. So we have to know what a rectangle looks like. So I'm going to draw one up in the right hand corner and then label my sides width, width, length, length. To get the perimeter, we have to walk all the way around the rectangle. So if I walk all the way around, that's going to give me 14 feet. So then notice how there's two lengths and two widths. So my first equation, if I walked all the way around to get the distance around as the perimeter, would be 2 times x, which is the length, plus 2 times y, which gives me 14 feet. So this equation models the fact that we're given the total length of both length and width of our rectangle to be 14 feet. So we're just having the combined value of each variable to give us 14 feet. Now the second equation has us compare the length and the width together. So we have to use our translating skills to be able to take the words and put them into algebraic form. We know that we have the less than keyword, which is, we know from before that we flip-flop the 1 and the 4 when you translate directly from words to an algebraic expression. So we have 2x. That is twice the length right here. We need twice the length. So then we have 2 times the length is equal to 1 less than 4 times the width. 1 less than 4 times the width. So 2x, which is 2 times the length, is equal to 1 less than 4 times the width. So notice how the 1 is second after 4 times the width, and these would be our 2 equations. Now your goal today is to figure out what the length and the width are for each equation. Come to me with the answer circled in your notes, and that would be your key, like the hashtag secret word. Alright guys, thanks for watching, and make sure you pay attention to the video and listen to it and follow directions and follow along. And don't worry about the secret word, just make sure you actually can solve the system and know how to write and define your variables.